Welcome back to this course. Today we are going to start with the lecture number 10. So, in the previous lecture we have started with the scientific computing, that how we can find the root of equation. So, we will go further. So, in the previous class we have discussed about the intermediate value theorem, and then we have discussed that with the help of graphics where we can find out that where the root lies. Now, we will take the help of initial intermediate value theorem, and suppose I have equation. So, suppose I take a function f x is equal to cos x minus x e raised to power x. Suppose this function I take and I want to find the root. So, in this case I do not know that where the function will lie, either because that now in this case it involves cos x, x and e raised to power x. So, one way is that I will plot function cos x, I will plot function e raised to power x, and I will see that where this intersect. So, that will be the place where we have the root. Another one is that I want to take the help of initial intermediate value theorem. So, in this case suppose I take f x 0. So, that will be cos 0 minus 0. So, this will be 1. Now, I want to calculate what is f1. So, f1 means cos 1 minus e, and cos 1 is basically, if you see, suppose I have a calculator here and I want 1 and then I put cos of 1. So, it gives the value 0.991. So, that is almost equal to 1, but we know that the cos 1, the value of the cos is 1 only when x is equal to 0. So, in this case what is happening? That is the problem, that we have taken 1 as a degree, but I just told you that we cannot take 1 as a degree, because whenever we will deal with the x, that is a real number, we have to convert this into the radians. And now I can find the value of 1 and now cos. So, from here you can see that cos r means in the radian, the value is coming 0.54. So, it is coming 0.540. So, from here I can write 0.540 minus e, and value of the e is. So, in this case this value will be less than 0 and this is value greater than 0. So, from here I can say that f0 into f1 is negative, the less than 0. So, I can from here using intermediate value theorem, we can say that a real root lie between 0 and 1. So, in this interval the real root lie. So, to find out the roots, we start with the first method, and that is called the bisection method. So, this is a very famous method, the bisection method. So, this method is based on the repeated use of intermediate value theorem. So, suppose we have equation f x equal to 0. So, in this case we will find out the initial I naught. So, let us suppose this is equal to a b. So, in this case my I naught can be 0 1. So, this is my I naught. Then I will do that with the help of this one. So, I will bisect this one I naught. So, I will get my bisection. So, I call it M1. So, that is a plus b by 2. So, this is the bisection we got, and I will get my another subinterval. So, this subinterval can be a M1 if f of a into f of M1 are less than 0. So, it means the root lying here, or it can be M1 b, because we know that this is my A, this is my B, and this is my M1 in between. So it can be this also, if f of m1 into f of b. So now this I will get my subinterval, that is called the I1. Similarly, I can go for I2. So I2 will be another m2, I3 it will give you another m3 and so on. So in this case I will get that this is my I0, I started with this one, then I will have I1, that will be I1 will be the subset of I0, then I will get I2, then I will get I3, and this is the sequence of subintervals I will get as we do the calculation. So using this one I will get the sequence of subintervals, and after q times process we will get our approximate root. Okay. So after this one I will get my approximate root in the subinterval IQ. So the subinterval IQ will be basically, I start with B0 minus A0, and this interval, the length will be this one of IQ will be B0 minus A0 by 2Q, where A0 is my A and B0 is my B. So that is the starting point we take, and then we divide by this one, I will get, so my I1 I know that is B0 minus A0 by 2. So this is the first subinterval I got. Second interval I got B0 minus A0 and then 2 square. Again I take the subinterval and so on. So in this way we are decreasing the length of our subinterval. So if suppose I get the interval IQ in which I got the root, so this is the length of the subinterval B0 minus A0 by 2Q. So from here I can write down that my bisection method can be written as my mk plus 1 will be ak plus half bk minus ak, where k is from 0, 1, 2 and so on. Okay. And the interval we got is ak plus 1, bk plus 1. So that is equal to ak mk plus 1 if f of ak and f of mk plus 1 are negative, and that will be equal to mk plus 1 bk if f of mk plus 1 into f of bk is negative. So this way we can find the bisect the given interval ak plus half bk minus ak, and based on this value of the bisect, if it is using the intermediate value theorem, this can happen, and this is my subinterval, the new subinterval at the k plus 1th step. So this is the way we can find the this is the way this bisection method is given for the given interval a and b. Now suppose how it works. So let's do the work of this one. So in generally what we do, we make a table. Okay. So the table means that this is the iterations, and that is the k. So k start for first 2, 3, 4, 5 and so on. This is the iteration we have. Then I will get my a k minus 1, a k or b k minus 1. Okay. So in this case that is the value of, so 1 I will get, that is the value starting with this one. So that is the value of the bk, and then I will get my mk. So mk will be ak minus 1 plus bk minus 1 by 2. So, from here I will get the value of this, and then I will find the value of f at mk into f at ak minus 1. Only one value I will check, and based on this value I will say that what is the where this value is going to come, because so let us do the same example. So, I will take fx equal to cos x minus x e raised to power minus x or e raised to plus x equal to 0, and I know that f0 in this case was 1 and f1 I have taken, so that is coming 0 less than negative. So, from here I can say that my a0 is 0. So, my a0 in this case is 0 and my b0 is 1, and the root will lie between 0 and 1. So, I will start with here. So, I will take first 0 and this is my 1. Then with the help of this I will get my m1, and that is 0 plus 1 by 2, it is 0.5. So, based on this I will find the value of 0.5 into f0, and f0 is 1, that is positive. So, I will try to find the value of 0.5, then based on this one I will see that my m1 will go here or here. Okay. So, maybe we can find the value of this, because this is just I am using the calculator. So, I will find out. So, I am doing everything in the radians. So, this the value 0.5 I have to find. So, this is 0.5 cos. So, that is the value of 0.5. So, my 0.877 minus 0.5 multiply by exponential. So, there will be the exponential term, exponential 0.5. So, it is, I hope it is. So, this is the value we have calculated. So, cos 0.5 minus 0.5 into e raised to power 0.5. So, it was coming 0.877 minus 0.5 into this 0.5. So, based on this value I will try to find that whether my, because suppose this is negative. So, if this is a negative, then this AK will be the same, and I will take M1 here. If this is negative, suppose this is coming negative, then I will take M1 here. If it is positive, then I will take M1 here, and this becomes BK. So, these things we can do in just in one go by making a code in the Matlab. So, let us write the code in the Matlab. So, based on this, first I will do that how we can stop. So, based on this, now we do that how much is the permissible error in this case. Now, we know that the b minus a naught is equal to 2 raised to power k or 2 raised to power n. B naught minus a naught 2 raised to power n. Suppose this is the nth iteration and I got my root. So, that suppose this is less than equal to some tolerance. So, this is the tolerance I have given. It can be a tolerance, suppose I have given the tolerance 0.5 into 10 raised to power minus 4. So, that is 0.00005. So, it is giving me the root that is correct up to 4 decimal places. So, in this case I am finding my root that should be accurate up to 4 decimal places. So, suppose I take this tolerance, and suppose this tolerance, based on this tolerance my iteration is stopped and I got my root. So, from here I can write down, then I take the value of natural log So b naught minus a naught by 2 raised power n, because we know that this is the in, the nth subinterval. So it should be less than equal to the log of tolerance. So what is the value I have? So from here I can write this log b minus a naught, right, minus log tolerance should be less than equal to log of 2 raised power n. So based on this one I can write this as log of b naught minus a naught minus log of tolerance, and this one I can write as n into log 2. So I can divide this one by log 2, so that is I can write by this one. So that is give you the number of iterations, that how many iterations we can have. So based on this one, so this is the number of iteration n. So n is the upper bound. So I can say that because my a naught is given to me, my b naught is given, I can find my log b naught minus a naught. Then I can find the tolerance. I know the tolerance itself, and then I can divide by log 2. So my number of tolerance, number of iteration will be always greater than equal to this. So based on this one I can say that this basically that how many number of iteration is needed to find the roots in my nth value based on this tolerance. So based on this one I can say that how many number of iteration is going to take if I am going to use the bisection method to find out the root of equation. Okay, so let us start with the Matlab code. So we can do the directly go to the Matlab. Yeah, so after discussion with the bisection method, let's we write the code for bisection method. So in this case, so let's do this one. Now I will write a script. So in this case I will write function, and then I want to find out the output. So output is, suppose I give the output the root, that is value of the c, and this error I want to give, and yc or fc. So this is the value of the function I want at the root c. So this is equal to, I write bisection, and then I pass the argument. So what is the argument is required? So I want the function whose root I need to find. I need to give you the value of a, the initial approximation, value of b, the, because I have to give the two values of the interval a and b, and then I want to give the tolerance. So this is the tolerance I want to give, that how much accuracy it is needed. So from here I can write the comments there, that this program is bisection method. Then I can give the comments the input. So input is function f a ab, this is the value of a and b I have to give, and the tolerance. So tolerance I need to give. Then I can write here the output. So output will be the root, that is equal to c, value of the root fc, and error. So that is equal to error. So these comments we can write based on our understanding that later on if we want to open this function, then I should be able to know that what is the meaning of input here and what is the output of this function. And now suppose I want to save this function. So let us save this one. So the name of the function and the file should be same. So it automatically giving you the bisection.m. So I will save this one. So now it is saved as a bisection.m, and that is the name of the function, that is bisection.m. So now what I do is that, so from here I am getting the value of the function f. So I will write fa. So fa gives the value. So I will use the inbuilt function f evaluate the function f at a. So this is the inbuilt function I have used. Then I write fb. So that is also equal to f evaluate the value of the function f at p. So this is the I have calculated. Now I give the if loop, that if fa multiplied by fb. So if they are of the same sign, so it means if I write that fa is greater than fb into fa into fb is greater than 0, it means that they are the same sign. So in this case I will write the display. So it will show me that no root lies in the given interval. So that interval I can write as a b and semicolon and this one, and then I will come out from the if loop that I will put the end. So this is here so it will not go to the next step, it will return to the output value. So that's why I give the return. Now so from the bisection method we know that how much iterations are there if I have the value of a and b. So from here I will write the maximum it, because how many iteration is needed. So I will define a variable maximum iteration. So what I do the 1 plus round off. So I will do the round off, and then I will write this log. So log means is a natural logarithm, b minus a minus log tolerance. So this is what is needed. So that is there. Now I will divide this by log 2, and this one I will find out. So that gives you the maximum number of iteration. Why I am putting the round off here? Because this value can be a real number, so I will round it, and then I am putting plus 1. So that will be the maximum iteration I needed. Then from here I can write that f printf. So this will give the print on the file, but in this case I am not opening the file, so it will print on the command windows itself. So in this case I will want to print total number of iterations in bisection is. So this one I will put it here, and then I will write %d. So %d is decimal, it will show you the value in the decimal integers, and then I will close down the semicolon and then comma, and then I put max itr. So it will display the number of iterations is going to be used in this program. So that is the maximum iteration it will show you. So after that I will write, so I will start with my iteration. So I put itr is equal to 1. This is the first iteration I want. Then I will write if printf. So now I want to show the results at each iteration. So it will give you that the new line I want. So at itr, it is equal to %d. So it will show you that at the iteration number, whatever the number it come from here, it will give you the value here. Then it give you value of a, so that is m% or percentage, sorry, not m%, it is percentage 7.6 f. So it gives you the value that I am considering my f to be printed here at this value in the floating point form with the 7 digit and 6 digit after the decimal. Okay, so this one I want, then comma, and then I want to print my value of b the same way I am doing the percentage 7.6 f, and then I want my new line, so that it should be printed the new line, and then I will close down this one. So the first value is ITR, then value of a, then b, and this will I will close down. So that is my fprintf value. Now I will start doing the calculation. So I will do the for loop. So for loop I will start from 1 to maximum ITR. So this one I will write. Then what I will do, I will find the value of c. So c will give me the value of a plus b, and then by 2. So this is the new value using the bisection method. I have found the new value, that is c is equal to a plus b by 2. Now what I do is that I want to find the value of fc. So this is the value I want to find, evaluate this value of f at c. So this is the value to give you. Now if fc is equal to 0, suppose at this point the value comes f0, then what will happen? It means we reach the root, so a will become c and b also becomes c, and then it will, in this case nothing I need to do. So if it is not happening here, then I will write else if. So if this is true, it will come, if it is not true, it will go to the else if. Now the else if I want that f b multiplied by f c, and I will see this sign. So if the sign is greater than 0, so this is the sign, if greater than 0, then what will happen? It means that b will is equal to c, and fb is equal to fc, else a will be c and fa will be fc. So this will happen, and then I will put the end. So this is the end of the if loop. Then I will put, I change my iteration. So iteration will become ITR plus 1, because I have to increment the iteration, and from here I will write the same thing I want to write. So I will copy this one, command, and then if b minus a is less than tolerance, so suppose it is less than tolerance, then I should break, and then I should come out from the program, and then I will write end. So this is the value. So that is the at iteration 1. I can write here initially initial b. So at iteration 1 I am giving the value at initial a and initial b, whatever the value we are giving, it will display here, and then after that my iteration will start, and this will keep continuing like that. So after doing this one, so it reached a maximum iteration, then I will, after this I will write c is equal to a plus b by 2. So that is my c, and I want to find the error. So error will be, I will find out the absolute value of b minus a, and then my fc So that FC will be f evaluate the value of f at C, and this will return from here. So my FC is there, C is there, and error is there. So that is the program I think we have done. Now what I want to do, I want to call this program from some script file. So now I will also start a new file. So this is the new file. So in the new file, we always want that if the any previous file is opened, that should be closed. So what I do is I will start always with clear all and CLC. So this will I have to write. Now what I want to do is that, suppose I want to find out, now I need a function f to start with. So I will write the function f is equal to, I will write the anonymous function. So at the rate x, and then I apply cos x minus x star exponential x. So this is the function I just defined, and now based on this one, now I want to give the value of a and b, that which value of a and b should be given so that I will get my solution. So in this case, in the previous example, this example, suppose I start with value of a is equal to 0. I don't know that where the value is this, and I will give the value b is equal to 1. So let's start with this one, and then now I call this one. So I want root error and y root or f root, the value of f at root. So this is the output I am going to get. Now I will call my function bisection, and then I will pass the value of f, then a, then b, and then tolerance. So this tolerance I have to define here. Now what I do is that I will define my tolerance. So tolerance I am defining maybe 0.5 into 10 raised to power, suppose I take minus 4. So this is the tolerance I am defining, that I should get my solution correct up to 4 decimal. Okay. So I will save this function as main function or calling function. So I will write it as main function, and I will save it. Now suppose I want to run this one. So let's run this one. So it will give you that some error has happened. So this is the call function I have called. So here it is written that undefined variable in the line 5 in the bisection. So by mistake I have written this one. So at the line 5 here, so you can see that by mistake I have written like this one. So FE value. Now it is okay, I think. Yeah, so it is okay now. Now let's run the code again. So this is the code, and I run it. Now if I want to check the solution, so that gives me the command. So this is the solution we got. I have started with the total number of iteration is 15. At iteration 1, initial value I have started with a is equal to 0 and b is equal to 1. Then what is happening at iteration 2, it will be a 1 plus 0 1 by 2. So it will, a will be 0.5, b will be this one. At iteration 3 it will be this one. So after doing all this iteration, ultimately in the end, so we have a 16 iteration, but maximum iteration 15, because the first iteration I have just taken starting from the 1, because otherwise it is my initial iteration. So I should start with the 0 also. So in this case, if I write this one, so in the final end I will get my solution, that is 0.5177. So that is my solution after doing this 15 iteration. So maybe I can change the number of iterations here. So this is my code, and I can start with 0. Okay. So, 0 means at iteration 0 means the initial value, I am giving this value, and after this it is calculating the value of this function. So, this is f, I am doing this one, and now I can call from here. So, now I can maybe I can change my accuracy. So, I will give the value, tolerance value is equal to maybe 3, because once I change the tolerance, the number of iteration will also change. And suppose I run the code. So, if I run the code, I will get new value of this one. So, in this case the number of iteration, maximum number of iteration is 12, and this starting from the 0. So, this is my initial approximation, and after some time you see that is my solution. So, at iteration 11 you will get A is equal to 0.175 and B is equal to 0.18066. So, in this case it is not reaching to the up to the tolerance, but we have started our code with the number of iterations, and the number of iterations I am taking always maximum iteration. So, it will not run more than the maximum number of iteration. So, in this code the maximum number of iteration I have defined, and then maximum iterations is not giving me the solution up to this tolerance, or maybe if I want to increase, I will take the 5 number of iteration will increase, and then so that is my solution now. So, in this case the number of iteration become 19, and that is my initial conditions, initial approximations, and with the time after iteration 18 my solution is this one. So, that is the solution we are getting. So, 5.5177, 0.5177. So, up to 4 digit or 5 digit is giving the accuracy. Okay. So, that is I am going to get. Now, I will, somebody says that okay, I want to change the initial approximation. So, instead of A I want to start with maybe -1 and then B is equal to 1. So, let us see what will happen. So, in this case if you just see, the iteration becomes 20 and it is starting from -1 and the B is 1. So, in this case after some time, and in the end after the 20 iteration, at iteration 19 you will get this value. So, that is the value we are getting, because in the code we have written that this is the code. So, I have given you that for if I is equal to iteration, maximum iteration it reaches, then do, but in between I have also written that if B minus A is less than tolerance, then you just stop. So, in this case you see that the number of maximum iteration is 20, but after the 19th iteration we got the solution, because here the value of B minus A is less than tolerance. So, it will break from the loop and it will come out. So, that is why this code we have written like that. So, based on this one I can find the value of, so this is, and this is my workspace A, B, F. So, in this case I can find, because somebody wants to see that okay, I do not know the value of F, where this value is coming. So, I have defined my F, and now suppose I want to find out that what is the value. So, maybe you can check F, you can try with values of F maybe at -2. So, that gives the value minus this. Then I can try here. So, it gives the plus value, it gives the minus value, then the plus value. One, 2. So, the one root is lying here between F2 and F1. So, this one I can check also by the code F0. So, F0 gives the F at 0. So, that is the root we can find from the inbuilt function, and that is the root of this one. So, based on this one I can, just to verify that whether my solution is giving, code is giving the solution. So, I can find from there that this is my root, or maybe I can define the root near minus 1. So, near minus 1 I can find the another root, and this is my root. So, in this case, based on this one, the real value of this, I can find the roots based on that where this point is lying. So, because from here you can see that f minus 2 is giving this value and f minus 1 is giving this value. So, one root also lying in between. So, let us in the code, so let us write this one. So, that is the main. So, in this case I will define maybe minus 2 and minus 1, and let us run this code. So, that is the value after the 19. So, total number of iterations are 19, and after the 18 iterations you can see that my root is coming, and that is a is equal to minus 1.8639. So, this is the another real root we can define, we can find with the help of this code. So, that is the initial code on the bisection method. So, maybe today we have started with the basic, we have used our basic knowledge of Matlab to write the first code, that is the bisection method, and using this bisection method we can find the root for the various equation based on this one. So, in the next lectures we will continue with this one. So, thanks for viewing, thanks very much.